All right. Hello, everyone. My name is Colin Schurek. I'm a third-year pharmacy student, and my presentation is addressing pharmacokinetic knowledge gaps through literature review of bacterial and extracellular vesicles. Also collaborating with me is Dr. Ravi Patel, of course, and Nick Pirolli. He's a PhD candidate, soon presenting his dissertation, and he's located in the University of Pittsburgh. So the background of my project revolves around these things called bacterial extracellular vesicles. Also known as EVs, these are a novel therapeutic delivery mechanism which have pharmacokinetic properties that are not really known and an unclear pathway to regulatory approval. So in order to illustrate this sort of unknown concept, I have this diagram here. So these are some two busy diagrams. I won't step out of the camera, but the diagram on the right over there shows basically what they are. So we have a bacterial organism here, and this organism secretes these extracellular vesicles. And these extracellular vesicles are kind of like they have a lipid bilayer, and they're kind of like a liposome, but they're a little more biologic. They have transporters, they have and all sorts of things attached to them, and they often normally the bacteria uses them to transport things such as virulence factors and other things necessary for bacteria's growth and development. But what scientists have been doing, they've been harnessing this for therapeutic purposes, such as with vaccines and other drugs. So what we've been working on, and what I've been working on, is that there is an unclear regulatory pathway for the approval of these drugs. And what I mean by this is that there's not much literature surrounding these. And so there's a company called Interact Bio, and then Nicholas Pirolli from the University of Maryland is one of the co-founder of this startup. And he seeks to utilize his bacterial extracellular vesicles in a unique fashion. And so part of my project was to help him harness these molecules. So the problem here is that it's unclear first of its kind pathway to regulatory approval. We have a need for readily available bacterial extracellular vesicle and EV pharmacokinetic data that the company can easily reference and easily utilize. And so my deliverables for this project were to create a reference spreadsheet for the use of stakeholders, and the stretch goals for this project were to create a pilot PK study that could be used in the regulatory landscape for this project. Fast forward 2 slides. So the workflow and progress of this project was the first I had to familiarize myself with the topic of extracellular vesicles and bacterial extracellular vesicles, utilizing articles that I was given from external stakeholder Nick, because I wasn't familiar with this topic at all. Then I had to investigate the FDA's current standard extracellular vesicles and create a summary document of findings, because they're a very controversial topic and there's lots of conflicting information surrounding them. Then the next objective was to conduct a broad range of literature search of scientific papers on topics relating to these EEVs and their PK properties. And I would collate this data into a giant spreadsheet for the reference of Nick and his external stakeholders. Also, I would perform an in-depth analysis of select papers from the spreadsheet, looking at other intricacies about safety, efficacy, and other properties that could be utilized with this with the papers. And then, of course, the stretch goal was to design a pilot PK study, what would be first in human and preliminary. The progress as of December 2024 has been creating this spreadsheet, cleaning and refining it for use by these external stakeholders. And we're still working on possibly designing a pilot PK set that could be utilized by the external stakeholders. So, I think they might be able to see it. Yeah, so this is just showing what the paper is, or what basically what the spreadsheet is. Although it's supposed to be refined here, it has, we currently have 20 papers in it I have 20 papers in it so far, with a broad range of basically time points and PK points, and then my analysis of said PK points and the conclusions of these studies. And this was like a good document of there, and then conclusion statements of what they can get out. Basically, that you can just view this document and then just get a good understanding of what the paper means. So the next steps of this project are to create and refine the pharmacokinetic experiments, consult the external stakeholders for feedback and refinement of both the deliverables, and continuously update the document with the current literature to make sure it's up to date. So the key conclusions I got from this is that PEVs and EVs, these are novel therapeutics, and that if a drug is has poor EV characteristics, that these therapeutic mechanisms, these drug delivery mechanisms, they're great ways to enhance its characteristics. And the literature regarding the pharmacokinetics of EVs is limited because a lot of it's kept behind closed doors, or that it's very hard to find. And that is one thing that was a limitation of this social topics, but it's one thing that was a conclusion of it as well. But yeah, thank you so much.
One last round of feedback if you want to take 2 minutes to answer the questions of what went well, what suggestions you have, and a thank to our colleagues from Pharmaceutical Sciences for joining us, and to Colin for taking on such a challenging project. Similar to what I asked with digital therapeutics, it would apply here. How do you deal with something that's so new and so broadly developmental? One thing I'll kind of reframe that is to ask, your P3 curriculum is heavily clinically oriented this time. You're learning a lot about pharmacotherapeutics, you're learning a lot about disease states of delivery. How do you think you have to balance the work that you're doing as an area of concentration, great focused in research, with the clinical content that you're getting out of the curriculum? What's the benefit or challenge?
I think one of the benefits I saw from this is seeing where the PharmD and the pharmacy curriculum, where the I guess the translational component can come in, where I can provide my expertise, the clinical side, and show my experience with patients and my experience with drugs and all these intricacies, how I can advise that to the research I was doing of the wet lab, the bench components. I think that really came through just looking at these papers and advised a lot of the decision making of even just making a spreadsheet and my decision making when I was designing the experiment. Well,
A fantastic case for translation. And I think we did have Nick Pirolli joining us. If Nick wanted to share anything either in the comments or through the audio, you should be able to share.
Yeah, absolutely. Thanks for having me, and fantastic job, Colin. It was a pleasure working with you, and I was consistently impressed at your ability to interpret a lot of really weird bacterial vesicle biology I was throwing at you, and then have the additional challenge of not having much literature out there in this field. And so just excellent job. And I think the work here is fantastic and will directly support designing mouse pharmacokinetic studies in the coming months. And then if all goes well with the company, like you mentioned, a first-in-human pharmacokinetic study to hopefully develop a new type of therapeutic modality for many different types of chronic inflammatory diseases. So I just, again, really wanted to thank you for your intelligence and effort in the project.
Another quick round of applause for Colin.